To learn what's new in Alplan 2025, especially for civil engineers, I will hand over to my colleague Selka Devetic, Team Lead Sales Enablement and Consulting Infrastructure at Alplan, who will guide you through all our online sessions covering infrastructure design.
Thank you, Ilona. Thank you very much. And welcome also to our sessions related to the infrastructure news in the version 2025. As a first speaker today, I have someone from Team Road, and we will hear more about newest development. As the title says, we will focus on the enhancements in the parametric modeling of intersections, and also we will hear about embedding for DTM surface creation. Today here with me is a product owner for Road, Michael Grad, coming from Graz. And he studied at the Technical University in Graz, and after that he gained some experience in the planning infrastructure offices, and he's trying to then implement his knowledge and experience in each version together with his team for road design. Hello, Michael. It's nice to have you here today. And it is very nice. Hello, and it is very nice to have you here to lead us through the latest development of the Alplan road design for 2025. So please, you can start whenever you want, share what you have for today. And I would like to know, before we start with the new features and presenting them, maybe you should give us a short overview about the existing workflow in Alplan for road design. For all those who didn't follow, who didn't catch up with old versions, just tell us how we already support our customers in this part. So please, you can start. Thank you.
Thank you, Shelka. Very much for the introduction, and welcome to the presentation of the innovations in the area of the road development for the version Alplan 2025. For those who have not had or who had little contact with Alplan road design in the past, I would like to start by summarizing the workflow already familiar from previous versions. The starting point of every road project is the road axis. This can be created in various ways, imported or simply taken from a polyline. As soon as the horizontal geometry has been defined, the vertical geometry can be created, which can also be imported directly from a table. The cross-section of the road is created parametrically using model templates. These templates are easy to create, can be combined as required, and can be adapted and exchanged at any time, which ensures high degree of flexibility in the event of project changes. The road junctions can also be created parametrically. Individual parameters can be changed at any time so that the model always remains up to date. Plans and reports are created directly from the current status of the 3D model. In the new version, various small improvements have been made to the drawing representation of intersection areas.
Thank you. This already looks quite powerful, I must say. But let's now focus on the new version and show us, please, what are the new features offering and how they are enhancing workflows of our customers. Thank you.
Okay, with pleasure. So the most significant innovations in road construction concern data preparation of the 3D model for export in IFC 4.3 format. Another improvement is the creation of terrain models based on modeled road objects. Let's start with the improvements made related to IFC data export. First, the project must be divided into construction phases. Each construction phase must be assigned a drawing file on which the road objects of this section are to be created. With the common IFC data preparation command, the desired axes are selected for object creation on the previously defined drawing files. This process can be repeated whenever model changes had to be made, and all attributes that have already been assigned to the road objects in the target drawing file are retained even when the geometric project geometry changes. With the IFC export, all road objects are generated in the user-defined attributes, are available for project collaboration between the stakeholders. The second major innovation for road design relates to the improved DTM creation functionalities. Let's take a brief look at it and determine the resulting benefits. It is now possible to combine multiple road structures within one digital terrain model. All you need to do is select the underlying base DTM and the axes that are to be used to create the new terrain model. Pay attention to the order of the axis, which is relevant for the calculation. The function can be used to create a terrain model of both the road surface layer and the excavation base. The result can be used for further excavation and fill calculation or exported as IFC data.
Thank you. But your team is also developing a complete range of functions for editing and managing DTMs. Can you then please focus on that? Show us a bit more about this particular part, and also tell us what kind of enhancements this brings to the workflows of our customers.
Sure. So there are several improvements made on the terrain side. We implemented a function to compare two terrain models by creating the volumetric bodies between them. Another improvement relates to the creation of 3D solids between DTM. Furthermore, we improved the workflow to ensure the transfer of DTM to the cloud and to Allplan Civil. Let me give you an impression of how these new features make your work easier. Comparing two DTMs is very user-friendly and intuitive. By simply selecting the terrain models to be compared, the volumes are listed in a table at the same time and are created in the model at the same time as 3D objects. The results can be saved directly as a list, or the 3D solids can be evaluated by using Allplan reports. As mentioned, it is now possible to create 3D solids directly from the DTM surface. By simply selecting the dedicated area, the 3D objects can be created. This function is especially useful for further modeling with excavation pit features. Finally, I would like to present the new capabilities related to transferring the digital terrain model to BIM Plus and Allplan Civil. In the cookie cutter function for area-based terrain reduction, it is now possible to avoid cutting the boundary triangles of the selected polygon area. If this cutting function is selected, the terrain can be displayed as an IFC terrain. Together with the visual style, all attributes required for data export are automatically assigned to the terrain surface. With the well-known Allplan export functions, the terrain can be transferred very easily to BIM Plus and loaded from there by Allplan Civil. With this improvement, we were able to close an important gap in the comprehensive infrastructure workflow. In summary, I would say that the new version has improved the data comparability and traceability of results. In addition, many small optimizations in the modeling processes bring advantages in terms of usability and efficiency.
Thank you very much, Michael. It was a pleasure to have you here. And what can we say? We look forward to test the new version, to try the new features, and also we look forward to the great new development for all future versions in Allplan for road design. Thank you for being here.
Thank you very much, Elka.
and we go further with our infrastructure session and the news. Goodbye.
Bye.
Hello and welcome to another session related to the new features in Allplan Civil 2025. I'm happy to have today with me here Jan Ostash, Product Owner for Civil. Jan holds a master's degree in bridge engineering and has knowledge about static and dynamic analysis for bridges, visual programming, and also different advanced bridge techniques. He joined the Allplan infrastructure team in 2018, and since then he was enhancing his knowledge in all these fields. Jan, hello. It is very nice to have you here with us today.
Hi, Jelka. Happy to be here.
Hi. So you are here today to tell us a bit more about the features, the newest development of Allplan Civil. And more specifically, we will talk about quite a lot about precast girder bridges today. This whole version was really with focus on precast girder bridges, and we can say the solution with this version we have, and we cover the full life cycle of this bridge type. We go through all the phases from the fabrication up to the last end stage.
Yes.
So you will tell us a little more about the new features later, but before we begin, I will ask you to tell us what was the motivation for developing these features for this bridge type, and also to explain just shortly what actually means one and what contains one life cycle of one precast girder bridge, please.
Okay, thank you, Jelka. With pleasure. So, our motivation was because there have been recent reports that have highlighted the urgent need to repair aging bridges worldwide. And to address this, we decided to offer a solution throughout precast construction, which allows for faster and more efficient rebuilding. And by incorporating precast elements, we can help accelerate bridge renovations and improve long-term durability. And of course, a bit just for the understanding, we need to understand how many phases we go through when we are talking about precast girder bridges. It usually starts with design and engineering, and then we have everything from manufacturing, transportation, installation, operational use, rehabilitation or replacement, and at the end, of course, the end of life and the recycling of the bridge. In our newest version, in our precast girder solution, for detailed analysis, we cover the phases from design engineering, manufacturing, up to the operational use.
Okay, thank you, Jan, for explaining this shortly. But let's now focus on the new key features in this version, which were really specifically designed or developed for precast girder bridges, and how they will support and enhance the workflow of engineers dealing with such a bridge type. Can you tell us, please?
Of course. When we are talking about precast girder bridges, we usually talking about tens of, if not even hundreds of girders. And then we have to have two key things. It's to have a good overview, a good management of data, and to have reusability of data. And the first key implementation are construction templates. Construction templates allow the user to define a process, for example, how a precast girder is fabricated, how it's stored, how it's transported, and in what condition it is lifted on the final position. And by defining these templates, we can reuse this data on any number of girders as we would like. The next key implementation is the time-dependent analysis, because each girder comes with its own history, which started already in the factory. And for this, we need to have a detailed analysis of the time-dependent effects like creep, shrinkage, and relaxation, which already start at the factory, so that we can correctly consider those effects on the final position. Additionally, we also need to account for accelerated curing processes, like introducing heat cycle into the manufacturing process, and this also needs to be considered correctly. Last but not least is the construction management. And with this big amount of girders that we are having in this kinds of project, we require a good overview of all the girders, of what is happening in a certain time and place, and that we are able to modify this data as we wish. Additionally, because the data from each element, from each single element is very important to us, we have also provided the user the ability to see an isolated view of a single girder and see, for example, all of the load case results that were happening already in the manufacturing process.
Thank you, Jan. These are some newly developed features for precast girder bridges, but there were also enhancements in the existing features in order to be more tailored for this bridge type. Can you also explain us which enhancements have been done to the existing features, please?
Yes. So there have been 3 features that have been enhanced. First of all, design and checks. We have extended the design and checks to account also for precast girders, for AASHTO and Eurocode. We have improved our automatic reinforcement generations, which comes now with additional features. It's now improved so that it can be also used on the precast girder solution. And of course, we still need to report all of this data. That's why we have also decided to extend our reporting engine to account for the data from each single girder that can be then easily through the reporting database can be then put parametrically linked to the reports.
Okay, thank you. And this will be my last question for today to wrap up with the key benefits from your side. What would be the key benefits for our existing customers or the engineers that are dealing with project requirements of precast girder bridges, and how we can support them better? So with these benefits that you
Okay, so at the end, we have 3 main benefits. At one point, this is time savings, because with the reusability of the data, so that we can define data once, like with construction templates, and then we can reuse it on any type of elements that we would like. We save time in the design and engineering phase of the whole process. Of course, with more accurate designs, like the time-dependent designs, we get safer designs, we get better results, and of course, because of all that, we at the end up using less material, which also means economic savings, so we also save money.
Thank you. And thank you for everything you said today. Thank you for sharing your time with us. And we can only say we are happy, and I'm sure also attendees and listeners, that to test the new version, to try it, and all the features you just explained. It already looks all very powerful, just by seeing. And I'm sure that it will bring significant value to the workflows that our customers already have. And speaking on that, we have as our next session one of the customers that had the chance to actually really test these new features, and they will tell us their feedback soon. Thank you, Jan, once again. Thank you for being here, and see you.
Thank you for having me.
Yes, see you in the next event. Thank you.
Okay.
Bye.
Thank you. Bye-bye.
Hello and welcome also to this session, which is focused on the improvements of automated reinforcement in Allplan 2025. Today with us, we have here Mobile Gidi, BIM Bridge Research Engineer. Mobile is a BIM specialist and an engineer, and he is working on digitalization of the bridge and other civil structures workflows. Hello, Mobile.
Hi.
Hello and welcome. Hello. So for the start, I would like to ask you the question why these features were necessary to be developed. Where is the motivation behind, and what are the key drivers behind the enhancements you did in the version 2025? And also how these enhancements will actually make the workflows for our customers more efficient.
Well, first I would like to say thank you for the warm introduction. And regarding the topic, this was actually released last year, but like you said, we did a lot of improvement for this, and we came up with different workflows that really support the reinforcement part of the design. Before I jump in, what are the improvements, or what in general the topic is for those who are newcomers, I'd just really like to recap a little bit about the modeling of rebars or reinforcements. So the question would be maybe better for you guys to answer it, or to brainstorm, like how do you normally do rebars? How do you model the rebars? So for example, let's say we have a simple structure here, as you can see, like an eye girder. So the question would be, how would you model this, or how do you do the rebars? Obviously, also you have to consider a lot of things on this, and regarding the time, regarding the efficiency and the precision, how do you consider all these things? And lastly, maybe the last question is like, do you reuse parts of the model that you did for the rebars? So if you did the rebars once, do you reuse them, or what do you do normally? So these are some things maybe for you to consider and to think how normally you would model reinforcements. And when I say reuse, normally, for example, if you have like a eye girder or like a precast girders, normally you have like similar components, so you have to redo the reinforcement multiple times. So this is something that you also maybe do differently, or you have a different workflow for that. But in today's, or like in this automated reinforcement, or in this new feature that we have, the idea or the goal is like to allow users like to create bars or reinforcements from quite simple definitions. So when I say simple definitions, you can see on the left side we have like a cross section. So this is normally the cross section that's used to model the structure in Allplan Civil. And this cross section is then extruded or like used, like I said, to create the structure. But what you do is like, or what you add here is that you just define simple definitions or property sets for the reinforcements. So here, as you can see, we have like this yellow line-ish. So this yellow line thing, these yellow lines, they are used to define the property set. So you can say I would want to have like a longitudinal bars, and you can have for example, you can see at the top flange we have a yellow horizontal line, which is used to define the placement of longitudinal bars. And you can see on the right side on the picture, we have like the blues, which are basically bars which are created or modeled based on the definition that the user uses. And if we go to one more step further, which is like a new feature basically on this version, the idea is we want to couple these different property sets. So like the definitions, as you can see here, which are defined by the users, which are quite simple. They did not have like any information about each other. But with this new feature, what we did is like we coupled them. So coupled them in a sense, we grouped them. So as a user, if you want, you can say, I want to group these things. And if you group them, it means either the transversal or the longitudinal bars, they will follow the other one. So you have the reinforcement group and they have a placement order. Also, you can say I want to place this one first and the second one next. And as you can see in the picture, like the bars, for example, the hooks are placed at the right position of the longitudinal bars. And so this could be achieved because of like the coupling feature that we have. And obviously everything is parametric because obviously in Allplan Civil mainly all the workflow are parametric because that is the essence of the product. And you can see here we changed the position of the pier and we already did the reinforcement. And if we change it and update the model, you can see the bars are also updated. So it's easily shown here and it's easily done. So you don't have to redo a lot of work in terms of modeling it back again and again. And of course, last step is of course the reusability aspect. So the idea here is that like once you do like certain things, and is there a way to save them and reuse them back again? And obviously the answer for this is yes. As you can see, we have a configuration setting where the user can configure different aspects of the bar setting. And you can see we have, for example, the hook angle, lengths, and so on and so on. This can be set and this can be saved. And once you save this, you can reuse it multiple times. As you can see, for example, this small bridge that we have, we can have different setups and we can reuse the setup or the settings and as a favorite and load them back on. And this brings me to conclude my slide and my presentation. And I would just like to say thank you.
Thank you, Mova. This looks really powerful. But this brings me just to another question for the end. Does this automatic reinforcement functionality actually applies only to precast girders, as we saw only these examples, or it can be used for other elements and bridge types as well?
That's a really good question, actually. So, like this presentation, I just kept it with the eye girder or like with precast girders, but normally you can use it with any structure that you can have or that you can model in Allplan Civil. Once you can model it there, you can just, like I said, in the cross section, you can just define the property sets, and this would be used to create the bars and the reinforcements. So normally it could be used with any structure that you'd want.
Great. I think this will make our listeners and our users as well happy. And they, for sure, as we are happy to test and try all that you did, all the enhancements with the version 2025. Thank you very much, Noel, once again for your time. And we are continuing with the program. Bye.